And we are live. Welcome everybody to the live stream. Today we will be focusing on building out the castle further using Houdini digital assets for the architectural construction. I have a lot of different HGAs that will be used for the architecture on this castle, but they can also be used for other types of buildings and houses and so on. But castles are a good foundation for the basic features of architecture. Okay, let's see. Okay, so first I will clean up my network. So right now it's kind of a mess. I do have this set of houses, random angles. First, before I organize this part, I will add a transform. See if that's it's more interesting. Not so much. That's fine. I'll leave it like this for now. And this will be our little example of a let's say a residential area. Okay, and I will give that a color red. Let's do a lighter salmon red. Let's do a circle. Actually, I'll make it a blue. All of these should be blue as well. Okay, and I'll put this in a subnet to keep it clean. In fact, actually that's good. And then for this one, this is a curtain wall. Okay, and let's see. Let's also put that into a subnet. Okay. Just keeping this more organized now. And this is just a, I'm gonna call this a tower. That's what it will be once we have the walls attached to it. Okay. And then this, I'm gonna remove this one. I don't really need that anymore. Let's take that away. And this one, let's call this font. Now fonts are a good way of stress testing how well the tool works, because text characters take up very arbitrary shapes, which is a good proxy for all kinds of scenarios you might run into when building HGAs. And when using HGAs on an actual project, it's a very good stress tester. I'll put that here, and this I will put into a subnet as well. Okay. Okay, and then this one last. I'll keep this one out in the open. This one can be our dynamic one that we're constantly changing. And let's call this custom. Okay. This creates a series of surrounding walls. I'm going to add a switch to this. We don't want that on for everything, so switch it on or off. But we do want to have in that the series of walls, we do want the original wall inside of that. So I'll add merge. think so. Okay. That's good. Okay. Okay. Let's remove this. It's just a piece of code that will come into play later on, but right now I'll just set it to the side and I will color it red. That way I remember to keep that. Okay. So now we have these walls and we can switch between these here. Well, this resample doesn't quite work with these buildings, so I will move that. Well, I'll just remove it for now. Okay. And I don't want to have any walls for that one. Okay. Let's remove that as well, and this too. These go with that, this find corners code goes in tandem with that, but I just remove these here, it's fine. Okay. Okay, and then we can, all right, that's good. And this part here is a, let's view the walls first, the actual architectural network here, which is applying to the UV islands of the building for all of them. Okay, looks pretty good. Now, if you want to have the these walls separated, all we have to do is add a facet node. So facet, unique points, that should allow the walls to be distinct. Waiting for it to load now. Some of this can take a while because it's operating on one piece at a time, which it has to, because it has to adapt to each wall. Longer walls will have more windows, very short walls will have no windows, and so on. So it has to adapt to each island. Okay. Let's take a while. Oh, I think I know the issue. So I'm applying a facet to each face, but there are a lot of faces vertically. I only want the facet to apply to each wall, not each face, because you see there's one face there, another one there, and so on all the way down to the bottom. So what this is doing is it's separating the points for each face, creating all of these distinct faces. But I only want distinct faces for each wall. So what I can do is I'll just remove the points distance on the line here. Just make that none. Okay. And this should be a lot faster to yeah, that's what we want there. That's good. Okay, right. Okay. Okay, and now let's view that. Now it's only 180 faces, which is what we want. Not like 72,000, whatever it was listing. That's good. That's great. And we can see these small walls have no windows now. There's no strange curvature between them either. Okay, that's great. Now I am curious how this looks in the in Karma render engine. Let's view it with the characters in the scene first. Okay. All right. Now let's view that in the viewport here. And it loads pretty fast too, which is great. Let's make the grid smaller. That way, when I focus on the scene, it's not going to go all the way out here. I guess I could always jump in like that and then view the grid. Well, I'll do that. But I do want the grid reaching out to the horizon line. Okay. Yeah, it looks like a little village. I don't really like these keyhole doors here. I'll fix that. And I'll work a bit on the. I'll show off some of the architectural tools that I've developed. Make this a little bit more interesting. Okay. Yeah, let's jump back into the castle softnet. Okay. First, let's just see if what happens if we have some of the buildings be taller, some be shorter. And I think we can do that with a. Let's go with a. Let's view the buildings here. Let's go with a randomize, or let's do a noise. And let's call this mask. Okay, make it a float attribute. Let's view that here. Make it primitive, that way it's applied to the entire face. Okay, and let's turn off the raw value. Okay, so it's heavier contrast. Okay, now let's add a promote. So promoting from primitive to point, and let's do mask, and the new name will be P-scale. Oh, yeah, P-scale. And then let's put this down for now. Then let's plug in through here and see the results so far. Yeah, it seems to work pretty well. But I do want more control over the size of that. So let's add a wrangle. And let's edit the P-scale. So F at P-scale times equals, or let's do fit the let's read this here. How does this work again? I think it's we can put in the value here for the input, 0 to 1 to 1 to 0. Actually, 0.5 to 1. Just remapping the values. Didn't seem to work. Why is that? I think I'm doing this right. Fit. Let's read this. Float value. Float min. Float max. Float min. Yeah, I mean, this should be how it works at P scale. 0 to 1, and 0.5 to 1. Oh, it's not plugged in, obviously. That's probably why. Yeah, there we go. Okay, 0.3. Yeah, that's good. And let's make this 10. Okay. So now we have some randomized sizes. Okay. Now I do want this cleaned up. So I will go to the source here. And let's jump into there and let's clean that up. Solve. Yeah, it worked in this case. Okay, now let's see this applied to the walls. Okay, yeah, it seems to work pretty well. I like that. And let's read that with the characters in the scene. Well, characters, they're just proxy people. It's the Electra base model here. But it's a good proxy for seeing characters in your scene. Yeah, that's pretty good. I like that. And it's pretty fast too. I mean, this is great. Now I do want to fix this keyhole door that I mentioned. So let's just do that now. Back into the castle here. Okay. Okay. Let's jump into that. Yeah, probably want to clean this up a little bit, make it more easy to understand what's actually happening here. But right here, these are our doors. I will doors and windows, I should say. Let's make this blue, as well as a circle. Okay. This is. Let's unghost that. This is our door. So if we change the shape here of the circle, I should fix that. Yeah, now it's more of an archway. Okay, and this is our window. Okay. This is our UV island that we're currently working on. Okay. And let's just let's kind of start from scratch here. Let's remove all this here. I want to showcase how these tools work in practice. Let's remove that as well, and just removing stuff that we do not need to have here. And let's remove that too, and this just sort of kind of left behind Yes, let's move this to here. Okay. And this is let's move that to. We don't need to have that. Okay. Let's start from scratch. So we have our UV island here, and we can isolate a different one if we want to. First, let's plug this into the output. Okay. Let's view a different one. Let's go with a wider one. Okay, there we go. Let's hop into there, and now we have a wider one, a wider UV island to work on. But whatever we put into here, we'll be applying to every UV island on the mesh. So we have to make sure to use adaptive tools to ensure that it works for every wall element. Okay, so let's use the node get, and let's get our windows. Okay, and let's get to the door instead. Let's call this door and window. Okay, this is our door. Okay, and let's use the copy the UV network copy array. Okay, and let's copy that onto the mesh. Okay, and we can see it's filling in that UV island. Now let's offset. We probably want the offset that's between these windows to also apply to the island boundaries as well. Let's turn on the island here. Now this ensures that there will always be 0.5, whatever value we have here, between the boundary edge and the element that we add into this array. Okay, and we can always set the max value here too. So we can go with 3, for example, and limited that's to 3. But usually you want to have that's at a very high value to fill in very long walls. For short walls like this, it will automatically only calculate what it needs to use. This is just the maximum value. Okay. There we go. Let's go with 0.5. 0.75 meters between each door. That's good. Now I would like to have this applied to the floor, so I'm going to move this to the floor, and yet now this is on the floor of the object. Let's use a subtract boolean, surface to surface, and let's subtract this surface from the island. Now we have our arches. Okay, now this should work for all of the pieces now. Yep, that seems to work. As you can see, longer walls have more arches than the smaller walls, and smaller walls will automatically decide not to have any at all, which is great. Okay, exactly what we want. Okay, fantastic. Now I'm going to isolate this again. Let's go with a taller piece. I want a tall and wide piece. Let's just edit this here, and I'm going to create a larger larger one beside the rest of them. Rectangle. Okay. Let's go. That's good. Okay. And let's see that with the, there we go. Yeah, that's good. It's already tall like we want it to be. Let's isolate one of those tall and wide walls. We could do that automatically just by adding a group onto that. Group. And let's call this town hall. Okay. Alright, fantastic. Let's turn off isolation since we're already isolating it enough with this blast node. Okay. Alright. Let's isolate one of the longer walls. Yeah, so that way we have that inside of here to work on. Okay. I probably want to add some isolation features inside of the subnet edit network. That way you can dynamically choose which one you want to think about at any given moment rather than having to jump out and do that. So I'll probably add that to this. But let me write a note. Let me write a note inside of the inside of this here. Inside of jumping inside of here, we have the doors blasted into the wall. Now I want to have this only apply to certain sections of the wall. So let's go with a UV network slice, and let's cut off the sides there. So now it's only applying to the that centerpiece. Alternatively, we could switch this around. It's only applying to those side elements. Okay, let's view that here. Yeah, that's great. Seems to work. Let's turn off the isolation there. Yeah, seems to work. Let's jump inside and slice off that. So now they're mostly just on the corners there, 3 meters away from the wall. Okay. Yeah. So this gives us a lot of this slice UV network slice HGA gives us a lot of control for where we want to where we want the array to apply to on the walls. Okay. All right, that's good. Let's turn off that and let's do 5 meters away from the wall. For this piece, it doesn't really matter because it's so small. So 5 meters on both sides is going to fill the entire space that we're given here. Let's view that here. Okay. Let's isolate the larger piece again. Okay, let's work on this more. And let's isolate one of the walls of that piece, the longer wall. That's good. Okay. Okay, and let's plug that into here. Now I want to, so now we have these walls, and it's blank in the middle of the wall that we had. And let's turn off the isolated. It doesn't really apply much to these ones because they're not that large. So let's jump back into this and let's change this to something more like 3. You should start to see that on some of these walls. Yeah. Okay. Maybe even 2. Let's go with 3. I think everything needs to be larger in the this here. Let's make everything larger. You don't even need to have this anymore. There we go. That's more like it. There we go. So now we have these corner elements of each of these walls. Let's add a null here. Okay. So on each of these walls, we have a corner that's kept. Let's apply this brick generator to that wall that we do have. Okay. Let's plug it into here. Okay. Now let's extrude that. For each component, let's go with 1, 1. Okay, maybe 0.25 would be good. And let's make sure to include a back wall to this too. Let's make this these corner pieces only, let's go with 3 meters in against the corner. Okay, that's good. Now for the remainder portion of the wall here, let's isolate a larger piece first. Let's go with this longer piece here. Let's do a blast and select that manually. So we have this corner piece, and now let's fill in the rest of the wall with a different kind of wall. Let's, in order to get the inverse of the slice, we can use a node get, then grab that. The second output, which is hidden inside of this here. You can see that it's hidden in there. I didn't expose that because I want to keep it clean. So we have this node get to get that hidden output. Okay. Now let's plug that into, let's merge that with the rest of the stream here. Okay. This one here is just a basic wall. Okay. Let's not isolate that piece. Okay. And now we have that wall between these corner elements. That's great. Okay. Now I probably want to add some features for randomizing, an option for randomizing which UV islands receive certain pieces, like maybe only a certain percentage of UV islands would have the store instead of all of them. That would be interesting. Okay. Let's jump into that here, and let's view one of the larger pieces again, and let's add a poly extrude to that. Let's add a tan color to this. Okay. And then let's go with a gray for this. Lighter. Let's do that with our little characters here, and let's see that in the render view. A bunch of cardboard boxes right now. We'll work on this further. Okay. So back into the UV network. Let's isolate this larger piece first. Go into there again. And let's have both of these wall types to only apply to the bottom half of the wall. This top half will receive a different kind of wall. So let's do that by adding another UV network slice. So UV network slice. And let's go, let's go 5 meters down from the top of the y-axis. Okay, so now it's a shorter piece. Then we can get the opposite of this slice using another node get, and let's get that hidden output there. And now we can have a separate material applied to this wall element. But for now, I'll just give it another brick system here. Okay. Let's use that divide. Add, there we go. It's good. Let's make it more extruded here though, like 0.3. This should make it more distinct from the bottom half. Okay, now let's see that applied to all of the walls. Or some curious shenanigans with the shading, the mesh, but this normal node should fix most of the issues, but I prefer if that doesn't happen at all. Okay. Looks good so far. Okay. Let's make these corners larger. So isolating this larger wall again, and then jumping inside. Let's make it more like 6. Okay. Let's see how that. Yeah, that's good. Now we have 3 doors on the corners there. Which is good. Let's see it applied to all of the walls now again. Okay. Certainly an improvement. Let's go back into this slice. Okay, and let's make this first slice down from the top here. Not so much. Let's make it more like 3, maybe even 2 meters down from the top. So that way it sets a strip on the top there, which I think it might like more. Let's see the result of this. Now this does create some anomalies. I don't really like having these very thin strips. I'll have to find a way to address those kinds of issues, but not right now. Okay. Yeah, it looks pretty good. Let's see in the rendered view now. Wait for it to import. Yeah. Great. Now, back into the castle in this the network that creates these buildings. Let's just randomize. Let's see what happens. Ooh, interesting. Now that's because the slicer is cutting through the area that would otherwise have that door. Okay, which makes sense. This should be expected, actually. I think you'd usually have building that store anyways. But overall, I'm liking this. Yeah, I do like this so far. I'm going to view, let's change the sun direction on this. Yeah, I like seeing the light and shadows moving through the windows here, or doors. I like that. Looks nice. Let's add some windows to this here, along this top of this here. Let's back to the castle. Let's turn off, unpin that view, and let's make the walls taller, because they should never be this short. Okay, and let's the minimum half of this value, so it'll always be at the very least 15 divided by 2. What is that? 7.5. Yeah. Yeah, 7.5. Okay. So the minimum value for these walls will always be 7.5, because it'll always be, the minimum is 0.5 of whatever the highest value is, which is defined in this length here. Okay. Make that 20. So now the minimum will always be at the very least 10 meters tall. So this gets pretty tall. Let's view that here again. These buildings are very very close together. These alleyways, it's yeah, not great for air circulation. I mean, you might as well just join the buildings together at that point, which actually we could do. Let me test around with that. Let's go back to the subnet here, and I want to see about using the poly expand 2D. We can kind of join some of these buildings together. Projection plane. Let's keep only the outside. I'm not sure what's wrong with the shading there, but we can add a normal to fix that, I believe. Yeah. And then we can add a hole node to fix those holes. Maybe before the, there we go. Okay. So this should make them actually join together. If we want. We still have these very small holes, which we can probably get rid of by if we add a delete small parts. Maybe we can delete some of those smaller this works, needs to be adjusted. Let's see. Well, we can add a silhouette on the y-axis. There we go. Let's not even worry about any of those holes. Okay. And yeah, there we go. That's kind of what I'm looking for there. I'm curious if this actually, how well this works with the UV network tools. So we can see that here. Imagine mine cause issues with some of these walls. Let's see the result here. There's a lot of people inside. I mean, it's definitely unique. It actually works pretty well. Even in these thin areas, obviously there's the overlap, but that was already an issue anyways with the tool. Yeah, it works exactly how I would expect it to. That's great. Obviously, I'll have to address these overlaps at some point, but yeah, it was like a huge gathering of people. This is so strange, these walls. It reminds me of the bathrooms. This is the weird shapes this is creating. Rooms that don't really make much sense, and that would never be constructed this way in real life, like this here. Why is that even there? And this here is crazy. This is an alleyway. I'm curious how this looks in the final render view. Yeah, I mean, it's unique. The poly expand 2D can definitely be used to, you can definitely leverage that in this workflow. Okay. So back to this here again. Let's turn that off. Turn off the poly expand 2D. Maybe even make it contract instead. That way the alleyways are more open. That's always an option too. And might as well just on some of these buildings just add a corner to it, a large corner. Let's get the 3 meters wide, and let's randomize what corners have that subgroup. So points, call this random, and let's randomize the chance here. So let's go with 10%. Okay, maybe 20%. I don't like how it works with some of these walls there. It looks pretty bad. Maybe I'll go with only let's go with only 2 meters wide. Okay. And let's see the walls on that. And that's a bit strange. I don't really like that. I think I accidentally added added 2 segments to that bevel. Let's go back into this here. Yeah, I did. No, it should be here. 1. Yeah, there we go. That's what I want. Okay. Okay. Definitely better. I like that. Let's view this now. Yeah, you could easily generate an entire city with this. Some of these tools here. Um, I really like these buildings. Seems to be coming together nicely. I'm going to create a series of windows at the midsection here. Let's go back into the UV network. Okay. And then, okay. For this slice here, let's create another UV slice. And then, okay. Then node get for the inverse of that. Okay. We're grabbing the hidden output here that I don't have exposed. Okay. And then so now the door is applying to this section, and now we have that missing section, which we will apply to the windows. Okay. And let's grab window. Okay, and let's copy array, UV network copy array, and let's change the offsets. Let's go with 0.1, and let's apply that to the boundary as well. Okay, so it'll always be 0.1 against the boundary. And let's put the minimum of the window on the minimum of the UV island. So now let's plug that. Let's boolean this out of this wall. So boolean, and then let's set this to surface and surface. Okay, and let's plug that into here and see how that looks so far. Okay, that's good. And we can always change this. Yeah. Let's go with 0.5. Okay. And then let's do another one of these basic brick generation systems here, and actually for all of these, let's randomize how much it extrudes. So for this here, let's add a noise. Let's call this extrude mask extrude. Okay, and then let's view that here and set to float. Mask extrude. Why is there it is? There we go. And then take away the raw value here, and let's use a ramp. Okay. And then let's use that as a mask for this extrude. I think it's under a spline control. Yeah. Thickness. Maybe local control. Yeah. Yeah, here, mask extrude. There we go. And on this, let's not make it so extreme. Let's change this value here to be 0.9. So it'll always be at least 90% of the value that we decide here. Okay. Let's just copy this onto all of them, at least the ones that use it. Like this here, for example. Let's put it here. Okay. And then the same with this too. Okay. And then we can always change the distance on this as well. This one can be more out, like that. We can change the noise on this as well. Let's change the scale. Okay, now let's see the output here. Apply it to all of the wall pieces. All of the UV islands. What's happening there. I will ignore that for now. Let's see how it looks in the output. Certainly interesting. Yeah, okay. Let's see the light and shadows move through these windows. If you raise the sun, you'll start to see that. Right there. I think because it's farther away, it's becoming more blurry. So if we change the angular size of the sun, should see that there. That's good. Let's change the angle. Yeah, I like this. I like how easy it is to create these it's nice light and shadow scenarios. Yeah, it's pretty unique. have to make some more interesting structures for this castle. It's kind of ugly, like some kind of poorly designed brutalist architecture or something. Um, kind of thoughtlessly slapped together, which is kind of what I did. So let's make this more interesting. Let's jump back into the castle here and UV network. Let's just start from scratch here again because this is not that does not look very good, honestly. Okay. Okay. Let's take away these characters for now. Okay. I'm going to isolate one of these walls, one of these taller walls. Let's go 30 here. There we go. It's usually good to work with a big piece just so you can see how it applies. What's the largest application of what you make in the network? Sometimes when you're creating these variables, it's hard to tell what's going on with a very small piece because it won't be applying to that small piece. Like if you have a window or a door that's wider than the UV island that you're working on, it will just ignore that completely because it's too wide for it to use. So using large pieces in isolation is usually what I like to work with when thinking about these procedural modeling operations. Okay. So we have our window, we have our door. Okay, let's copy the door onto this here. So copy array. Array. Let's get that door, plug it into there, plug it into the wall, and add that boundary buffer. Okay. Okay, and I only want these being applied to the middle of the wall. Let's use a UV slice, UV network slice, and cut off the X-min. There we go. And now let's Boolean that. Boolean subtract. Okay. Okay. And I would like to have the array use the minimum of the door. Already it snaps to the bottom of the UV minimum. Okay. Plug it into the output here. Okay. Okay, and I would like it not to be in the middle of the wall either. So let's jump back into there and in the UV network slice. Now let's isolate this larger piece first. And then let's okay, something like that. Let's see the result here. Yeah, now it skips that mid portion there. Okay, that's a good start. Let me look at some of these castle architecture pictures. Let's create some like towers along each of these corners. Let's do that. Jumping into this here, and let's remove the bevel that we added here. Let's remove the poly expand. Okay. Let's make this more space between them here. Something like that. There we go. Okay. Okay. And then let's add a circle on the y-axis, and let's copy that onto the points. Let's add a wrangle here for the orientation. V at up equals V at n equals 0, 0, 1. Okay. Here we go. Okay. Make this large. Let's do 2 meters wide. Okay. That's good. Let's merge that. And then add a silhouette. Okay. Kind of like that. Certainly a unique shape. Yeah, let's go with that. Okay. And let's reverse this. In the future, right, this should happen automatically, but I'm just working with some default nodes right now for this, the base structure for the castle. Okay. Kind of an arbitrary shape. But okay. Okay, let's not even bother with this randomized scale. It's always going to be this length of 20 meters tall all the way through. Okay. Now I don't want to add the facet, but this is going to separate each of the faces on the curved wall, and then it will be applying this UV network to each of these pieces, and that's a lot of pieces for it to be operating on. Ideally, we only want this UV network applying to each individual wall. So basically reading the corners of the walls and then determining from that that each wall is, the walls can be curved like this. So facet's not a great tool to use for determining the walls, because curved walls will have multiple faces because it's based on polygons. So let's remove remove the facets, and let's think about this differently. Now I do have this fine corners here, and I think this maybe this can apply to the polygon geometry. Let's see. Corner. No, it's applying to the top and bottom of it. It's not quite working as I would want it to. Actually, it does seem to be working almost. Well, let's apply this only to the polylines before it's swept with the line. So on here, I think this should work. Yeah, I think it's reading that correctly now. Yeah, it's only it's only that corner for all of these pieces. It's not applying to that corner for some reason. Maybe I can change the angle. Yeah. Okay, so now it's reading those corners. Okay, let's sweep that and let's okay. It does seem to be working, even for this tiny one there. Okay. Let's convert that into an edge group. Group promote from points to edges. Corner. Let's see what. See if it applies correctly. Corner. It is creating this boundary one here. So if we remove the, okay. We might need to lower the corner to, yeah, lower this threshold. There we go. I think this is working. Let's view that again. The corner. Yes, okay. Okay. That's good. Now let's convert that, or promote that into a group promote that into a vertex group, vertices group, edges to vertices. Okay. now let's maybe we don't even have to do this promotion at all. Let's just use a point split. Point splits. And let's use that corner and see if that might work. Load view. Yeah, it seems to work exactly as I would want it to. Now I think that I might need to change the threshold even lower, like 45, 25, 10. Yeah, I might need to adjust the actual code behind this because it's not grabbing certain walls here. I think it's not. What's that wall there? Let's. It's that wall there. So let's see if it has it here. It might be losing that when I sweep it. Let's see the corner group. Yeah, it's actually not in the group originally, even when we have at this very low threshold. I mean, it's a not corner, but for some reason it's not in this corner. So I'll have to adjust how this works, I think, but not right now. Not as easy to follow Vex construction, unless it's simple. So let's just continue on with this as it currently exists. So it would have that problematic spot when we add the operation to the walls. Okay, so we have these different wall elements. It mostly works except for that small area there, where the curved element is attached to that flat one. But that'll be fixed later. But this is mostly okay. It mostly works. Now let's apply our operation. Fantastic. Okay, I like that. I think that's the problematic spot because that's the only one with only one door. And that's because it's reading it as the same piece as this one here, I believe. Because the rest of them all have equally 1, 2, 3, 4, 5 doors. Yeah. Except for these smaller ones, of course. Yeah, it is adaptive to the size of the wall element. Let's randomize the size of these towers. Go back to the it's here, and let's randomize the scale. So use a noise for that. So P scale float. Okay. Oh, that's why. Okay. Let's change the output value to be 2.5. Okay. So now we have more randomized sizes. Yeah, it works pretty well. I like that. That's a funny spot there. Okay. It's not bad. Okay. Let's randomize which corners have the tower as well. I don't think all of them should have it. Okay, and we can do that with a group selection group and random randomize a group. Then random. There we go. So now not all of the corners have a tower attached to it. Only 20% of the corners do. Okay. It's a very interesting abstract kind of cardboard looking towers. Let's create some more interesting brick deformation. I do have this these randomized brick shapes. You can see with the single pass. Yeah, these randomized bricks. We can use that in our put that into our network. I'll make this put here. I'll make this blue. Call this out brick. Okay. And I'm gonna get 20 variations of this brick. We have all these different variations. Okay. And let's plug that into our network. Actually already has it plugged in apparently. That's nice. And let's bring that in. The second input should have, let's reveal that. We have our that brick right here. So if you plug it into here, let's drop it into the slot like that, and it'll bring it into the network on the second input. Okay. Now I want to distribute that brick onto the wall. Okay. Let's use the node get, plug it into there. And right now, I'm going to isolate until it's just one of them. Let's go with the 0, the first one. Okay. And I'll move this to the side for now, like all of this here. We'll add that back. Let's keep it to the side for now. I want to copy these bricks onto that wall. So copy array. Let's create no border there. Okay. So we can fit in however many that is. And then let's do the minimum. Okay, that's good. Okay. I'm just going to copy this for now. Copy and transform. This manually, just for now. Just want to see how this looks. Okay. Yeah, not bad. Let's view it in the render view. Obviously, there's no mortar between the bricks right now. It's just the bricks. So there's gonna be a lot of light shining through those gaps. But let's see. It's taking a while for it to load because right now those bricks are packed primitives, and bringing those into SOPs directly, I think this is by default, converting them into not packed prim, so they're not instances when it's imported into here, I believe. So right now it's just converting those into regular primitives for each brick. So it's a very expensive operation right now, but in the future it should be working with instances instead, which will make it more or less automatic and very quick to render. But is it almost there? Let's cancel this. Press escape, escape, escape. White screen of death. Not great. Hopefully I can recover this. Yeah. Manual. Okay. All right, back to this. Let's Yeah, maybe I can unpack it here. It won't be as expensive. Oh. Oh, after you auto update. And it's pretty expensive here too. But I think less so. Now let's plug it into the output there. Now let's see it in here. Yeah. That's good. I'll be working on a system for I'll be modifying the copy and array network that I currently have. This copy and array, but right now this, as it currently stands, only adds an array on the x-axis. I need to add features for stacking it on the y-axis as well. Right now I have it manually doing that, and also manually staggering them as well. The problem with this is that it's not going to adapt to the UV island. We can see the UV island is larger than what we have in this copy. This has to be manually changed. That's why I'm making these tools, is so that it will automatically adapt to the boundary that you put it into. So yeah, I have to modify this and add the vertical array as well as the that staggering for the bricks. Okay. So I'll run the live stream here, and then I can return to this probably another day, maybe later tonight. We'll see. All right, everyone. I hope that you enjoyed the live stream, and hope to see you next time. All right.